Hi, my name's Jennifer and I'm in my final year of a PhD in physical chemistry. When people think of a chemist, they probably think of someone in a lab mixing colourful solutions in test tubes, but what I do is actually very different. I work with lasers and we use laser absorption spectroscopy to analyse the concentration of gases in human breath. This means that we can analyse oxygen consumption and carbon dioxide and water production far more accurately than anyone else has been able to before. This area of research has two main applications. The first of these is monitoring patients who are on ventilators in ICU. The second is lung function testing in patients with conditions like cystic fibrosis and chronic obstructive pulmonary disease, or COPD. I use a device which contains 3 lasers. As a person breathes into the measurement head, the laser light is shone through the breath sample. The laser light is at a very specific wavelength that's absorbed by the molecules that we're interested in. The more molecules that are present, the more light's absorbed. And from this information, we can work out the concentration of the gas of interest, so oxygen, carbon dioxide, and water. And then we also measure flow at the same time. So using these 2 bits of information, we can work out the volume of gas that passes through the device per unit time, and from that work out oxygen consumption, for example. My work's very varied, so some days I'll be working in a laser lab, and others I'll be up at the hospital, either taking data in ICU or working with doctors in a respiratory clinic to study patients with lung disease. I first came across this area of research while I was doing my master's project, and I was fascinated by the application of lasers to real-world health outcomes in patients. There's so many exciting applications to this work. For example, applying it to new respiratory diseases, or for example, adding trace gases to improve our modelling so that we can give people a better idea of how their lungs are functioning. It's important to say that I don't work alone. I'm part of a large research group with lots of different avenues of research going on at the same time. So for example, some of my colleagues are working on patients with asthma, whereas I work with patients with cystic fibrosis. Cystic fibrosis is a disease that affects patients from early childhood. So now we're studying children to help clinicians intervene earlier. In my parents' generation, children with cystic fibrosis weren't even expected to live until adulthood. One of the misconceptions about research is that people think that it's a linear journey from A to B, but in reality, that's just not the case. So, for example, there's bumps along the way, or there's whole new avenues of research that come up. In my work in ICU, there were delays because staff changed and moved hospitals. So that meant that I ended up spending more of my time at that point focusing on my other projects, such as my work with cystic fibrosis. I was also supposed to be working on a study at a GP clinic into people who are stopping smoking. But then, just as I was about to start the study, the clinic was cancelled. So I had to find a new way of recruiting participants. So instead, I ended up sending out many emails on university mailing lists to recruit current smokers. At the time, these kind of challenges can be really frustrating, but actually in the end, quite often there's whole new exciting opportunities that come about from these problems.